Welcome everybody to honestly the session that I am most excited about of the entire startup series thus far in 2022. Frankly, I am so far out over my skis on this one because I am surrounded by what I view to be the most intelligent people on the planet, data scientists today. So I will be serving as the host today. My name is Brian Deering. I am the Startup Success Manager here at Centrifuge. And before we jump into data science for startups with Elizabeth and Greg, just a couple things that I want to go through about Centrifuge if you are unfamiliar with our organization. We do a lot of things here. We are a nonprofit organization that is tailored to help startups win. We help startups win by connecting and catalyzing. So potentially that's data scientists with startups so that they can understand the data sets, machine learning, AI, all the things that are out there to help them make intelligent business decisions. But on top of that, we have a great team here. I am the Startup Success Manager. John Steger, who heads up the entire Startup Services division. Elisa, who's on our corporate side. So if you guys are interested in working with Procter & Gamble, Western Southern, or any of our other corporate partners, she's your contact. And then Abby Soder, who is our basically GM of Union Hall. We have 38,000 square feet of beautiful office space here. I highly recommend that you check out if you're a startup or if you're an enterprise worker that just needs a cool environment to work in. As far as the startup services organization, what do we provide the startups that we work with? We provide them a bunch of tools that can help them succeed. That includes unlimited access to myself and the entire startup services division. We'll help you polish your pitch deck. We can help you with financial and customer acquisition modeling, not nearly to the level of data science that we're going to get into here in a minute. We also have unlimited pitch book access, so we can pull all that competitive analysis that you need, help you size up the market. Have a partnership with EY if you need in-depth financial modeling that's well outside of my ability to provide. And then we have connections to all sorts of value partners throughout the ecosystem. So those are angel investors, private equity firms, venture capitalists, large enterprise, law firms, you name it, we can make the connection. So if you're interested in working with us as a startup, please go to centrifuge.com/connect. Love to work with any tech-enabled company within the greater Cincinnati area. And just go to our website to check that out for more information. So today's one's an exciting one. As I mentioned before, we have two data scientists that I have the pleasure of seeing because they work out of Union Hall. The first is Elizabeth, who joins us from Olive. And then the second is Greg, who joins us from Pieces. So one's a very, very large startup, while the other one is a up and coming rising star within the Cincinnati ecosystem and beyond. So, this is one of those things that I can tell you as a past founder, I didn't appreciate until, it was shown to me as far as the decision-making ability from the analytics that you can gather from any platform. Doesn't necessarily have to be a SaaS platform. It could be a brick and mortar store. The more data you have and the more data that you can parse and make sense out of, the more you can scale and make good business decisions to help yourself succeed. So that's exactly what they're going to get into today, as well as give us, a broad overview of data science. And at the end of it, we've got a big surprise because we're launching, well, heck, I'll just put the cart a little bit ahead of the horse. We're getting back into meetups here at Union Hall. Personally, when I was a founder, it was the place you went to when you were a startup to meet with other like-minded people that were just trying to win the way that you are. And our data scientists are going to kick that off for the entire organization. So keep me honest here. It's the third Wednesday of every month here at Union Hall. We're all going to get together. There's Eventbrite information on our website for that as well. Drinks will be provided. It's going to be a great event, but more information on that. So I'm going to do everybody a favor and stop talking. At this point, I'm thrilled to introduce Greg to you, and I'm going to go ahead and turn over the controls to you. So Greg, first and foremost, say something so we can ensure that.
Yeah, check 1, 2. Thanks for being here, Brian. Yeah.
And then go ahead and take over the screen.
All right, let's go. Everyone bear with me. Okay, how's that?
Awesome.
We're there. Cool. Well, yeah, appreciate the intro. Let's go. Elizabeth, you want to start?
Yeah, we're super excited to be sharing about analytics with you guys today. Like Brian said, my name is Elizabeth Gilbert. I'm a product data analyst currently at Olive, and have been a data scientist in past roles. So super excited to be sharing this with you guys.
Yep, and my name is Greg Sweeney, and I guess my life story is I've done software engineering and data science for the Department of Defense, and I worked in engineering consulting for a few years. I worked with startups and Fortune 500 clients building machine learning and AI solutions for them. And now I'm at Pieces, and we're a tech startup based here in Cincinnati. Okay, so when I was in consulting, working with a ton of different companies of different sizes, a lot of the companies there, they had heard of machine learning and they had heard of data science. And they knew that they were supposed to be using data science and machine learning and AI. They didn't really know how to start. Most of them didn't really know exactly what they were, what the difference was. So we're going to address those types of things and try to put it in the context of startups and how it affects you and your company as a founder. Or if you're an interested, data science enthusiast or someone who wants to get into data science, we'll talk about how you can start there.
Yeah. One of our goals here is to give you the vocabulary of data science. Maybe you've heard a lot of buzzwords flying around, but we want to connect the dots, maybe present some new terms, give you the foundation to be able to learn more on your own, to be able to ask questions, connect with data scientists and other people who are interested in data and looking to use it. So giving that vocabulary is one of our big goals throughout all of the parts of our presentation today. So things we hope you gain. Data science is diving deep into data. You can think of it as these three portions: software engineering, predictive intelligence, data-driven decision-making, all coming together. It's a really interdisciplinary field where you're using a lot of different tools to create valuable insights and solve problems. In different applications of data science, you might be using different portions of that more. If you have really advanced AI and machine learning algorithms, maybe it looks like a lot more predictive intelligence. And if you're doing business intelligence and dashboards, then maybe that data-driven decision-making is what you're leaning into. But overall, no matter where you're coming from in data science, we're going to be developing solutions for various business problems using often machine learning or deep learning. Data science, you might have heard of this concept of the data science unicorn. It's because there's so many different portions of data science, the statistics and the computer science, and applying that in a specific domain, needing that domain expertise. Finding a person who has all of that background, all of those corners of this Venn diagram, you can feel like finding a unicorn. And this is helpful to show the overlap, right? If you come from a computer science background and you learn statistics, you have a really solid foundation of that machine learning piece. But if you're coming from a business side, have a lot of domain expertise and you're learning stats, you're maybe getting into statistical research or getting into data processing and moving towards data science. And this is a helpful framework for not only understanding where you fit in, but understanding where you want to grow into, right? Maybe you find that you want to be more in machine learning, but that means you have to learn more statistics. And maybe that's a weak part of the triangle for you. So this can be a helpful framework for just boiling down data science into a few things that have a lot of overlap and a lot of different parts within them and components to it.
All right, so I'm going to try to break down the difference between AI, machine learning, and deep learning here, because the truth is most modern data science applications and algorithms are using some kind of machine learning today. A lot of them are using deep learning. And the way I see it, they're sort of subsets of each other. So artificial intelligence it's any kind of algorithm that simulates autonomous mental thought. So it's a program that can sense, reason, act, and adapt on its own. You can use it for knowledge representation, pathfinding, natural language processing. There are many more applications. Some of the examples that I've put here are IBM's Watson and AlphaGo from DeepMind. So DeepMind was actually acquired by Google in 2014. Machine learning is a subset of AI where the machine learning models actually learn to predict patterns from data. And every machine learning model just follows these 3 steps: extract patterns, and then make predictions, and then learn from those predictions. So some examples of machine learning models, a really popular one is linear regression models, which is just fitting a line or a curve to some points. Predicting the next stock price is an example, predicting user behavior, just following trends and trying to fit an algorithm to make those estimations. There are a ton of examples on the screen here. Robot navigation is a great one, just like making decisions about where to go, where to travel next. Diagnostics and fraud detection are really great. An example of classification and categorizing data. All of these things on the screen, they all share the same 3 steps: just extract, predict, and learn. And finally, we have deep learning. This is sort of the state of the art in machine learning right now. Deep learning it's a specific computing architecture of machine learning models that are set up to mimic biological brains. They simulate deep layers of neurons that learn patterns from huge data sets. And they learn similar to biological brains too. They learn by just looking at tons of examples of data. You can set up curriculums kind of like you teach children in a school. So we use this a lot today in computer vision, natural language processing, right? So like Google Home or Alexa is a good example. Tesla's driving automation is an example where computer vision uses deep learning to perceive what's in a video or in a LiDAR reading. So you'll see this more often than classic machine learning when you have huge amounts of data and there are lots of complex relationships in the data. These deep learning models have a lot of parameters that can be tuned in to just extract these really complex patterns from data. The examples I have on the screen are from DALL-E 2. DALL-E is, this is a really cool model. It was revealed last week by OpenAI. OpenAI is a nonprofit. They have a lot of venture backing. I think they're backed by Elon. And they released this model that can understand text and images. So what we're looking at here are some images generated by captions. A dolphin in an astronaut suit on Saturn in the style of ArtStation. It's really amazing stuff. There's a really basic depiction of the model architecture down at the bottom, but inside all those trapezoids and other funny shapes are these simulated multi-layer perceptrons. So they mimic biological brains. They pick out patterns much in the same way that biological brains do by just encoding and decoding information, from our senses, whether it's like images or video or other sources, and then picking out really complex patterns. So, at the end of development, these models can really understand, certain components in an image, and they can understand abstract concepts behind them. And they tend to learn a lot, and they're able to process information very quickly.
This is Gartner's analytics maturity model. You might have seen it before. It's put out in 2012, so it's been around for a while. But the reason I want to share it is because while this model might not be perfect, no model is. I chose a progression of analytics. If you've never done anything with data, the bottom left is the easiest difficulty to start with. Moving from descriptive analytics, where you can say what happened, to diagnostic, where you can say why it happened, predictive, you can say what will happen, and prescriptive, where you can say how can we make that happen. And the takeaway I want to point out with this model is that even descriptive analytics can be useful, especially if you don't have any analytics yet or any data yet. That describing what happened can also be a valuable form of business intelligence. Maybe, and it totally depends on situation. So maybe you are totally ready to jump into, or you have a product built around machine learning models, and you have the data scientists and the capacity to do that, and you're already in the predictive prescriptive analytics. So totally case dependent, but be excited and encouraged that those things are out there, but not discouraged if you're not at that point individually yet, because even starting at the first step for data, whatever that looks like for you, wherever you are, can add a lot of value. So when you're doing data science, what that process looks like can be helpful to add a little structure around. One of the tools that Greg and I like to use is called CRISP-DM. It stands for Cross-Industry Standard Process for Data Mining, and this is a diagram of the workflow. One note on data mining, if you haven't heard that term before, maybe you have, data mining just means mining knowledge from data. Sometimes when we say mining, we think of collecting things, but it is not data collection, it's collecting that knowledge from the data that you have. And so the process that this diagram shows moves from a business understanding back and forth to data understanding, onto data preparation, back and forth to modeling, onto evaluation, maybe adding that results of that evaluation back to understand more about the business, and maybe deploying that model into production. So those are the basic steps. You can think of it as 6 different steps to the process of data science. And if you're going to be doing a data science project or an analytics project, this can be a helpful way to break up those portions of your process. A couple of key things here. You notice that business understanding and data understanding together make up a whole third of this process. That understanding portion is really, really key, because if you don't understand the question you're trying to answer, if you don't understand your why, then you might be at risk of answering the wrong question, in which case your analysis isn't useful. If you're not answering the right question, then you have no actionable insight at the end of your analysis, and it wasn't worthwhile. So it's really, really key to understand the context and be on the same page about what the question you're trying to ask is. Sometimes people asking the question don't really know what they're trying to ask. Maybe they're asking something, but they really want something else. It's really important to prod and get at the truth there as a firm foundation. Another key call out, data preparation can go by a few different names. Sometimes we call that data cleaning. Sometimes we call it data munging. It's kind of a fun word there, but that step is known to take up maybe 80% of the time or the effort in your analytics, and that's because most data isn't clean. Most data isn't collected ready for analysis in the exact form that you want it. However much we may wish that just happened for us. That's a really important step, and it's important to expect to really be able to focus on that and get your data in the right form to do analysis and take action off of it. And conversely, modeling seems like the fun part that is the highlight of the whole model, but where you spend 80% of your time in data preparation, you might think that was modeling, but it's actually a smaller portion than you might expect. And it's just important to not think of the whole process as just modeling, but be aware of all the things that come before it and all the things that need to come after it to make the whole process valuable and add value to the context you're working in your company. The last thing I'll say on this model specifically is that deployment might look like putting a deep learning model into production, but it also might look like making a slide deck or sending a summary or suggesting an insight and action to the stakeholder of your analytics if you're doing an analysis or business intelligence. So deployment can look like a lot of different things in this context. My last suggestion with this is that personally, I use this to keep track of my files, to structure my folders. And it's kind of a way to check that I'm doing all these steps. I have a folder called 1, background, 2, cleaning or data, 3, whatever the type of analysis you're doing is. Maybe it's simply finding the correlation or relationship between a couple of sets of data or fields. Maybe you have a folder for exploratory data analysis that in your data preparation step, whatever that looks like to you, then the outputs. And my first project, I didn't use any of those. Everything was in one big heap, and you create more outputs and data as you go. So take what portions of this are helpful to you for understanding the process, and hopefully some of the ways that you'll interact with your data in different ways throughout the whole thing, and what you can expect if you're interacting with data scientists or you're becoming one yourself. Another thing to consider when you're working with data is understanding your data from a few different perspectives. So you can think of these as the 3 V's: volume, variety, and velocity. Volume is the size of your data, right? We would interact with data that is 30 rows long and in an Excel document much differently than we would interact with huge, very big data that maybe you have to store in the cloud and access not directly from your local, on your local machine. So that's important to take into account. What infrastructure needs do you have? And Greg will talk about that a little bit later. because of the size of your data. And that's not to say that all data has to be big data or that only big data is good. There's some contexts where getting, maybe surveys from people, you're not going to have, millions and millions of gigabytes of data. It might not be that quote unquote big data. Everything is relative to the context that it's in. But it's important to understand what the size, the volume of your data is. Variety is the number of data sources you have. Maybe you're just working with one data source. Maybe you worked with it before, maybe not. But maybe you're connecting a couple of data sources. That's one of the places where understanding your data is really important so that you're able to understand the relationship between the data sources, however many there are that you're connecting. Maybe you're finding a relationship, or you're understanding the cause and effect between a couple of data sets, but taking into account how you're storing all of them, what format they're in, how they're going to relate to each other is really important when you're setting up or considering what data you need to collect from what sources. And that's the variety of data. Finally, the velocity, the speed of change is important to take into account, because maybe you have a data set that is stationary. It's never going to change. It just was collected once and won't change in the future. But maybe have one that changes infrequently, like census data changing every 10 years. And maybe you have something that's updated much more frequently. Maybe it's event data and it is updated whenever an event comes in, or it's updated many times a second or minute. That velocity is probably going to impact the size of your data. If you have a lot of aspects of the data, a lot of features that are being captured every single time you have an update or addition to the data over time. So these things all work together and are really important to consider when you're thinking about how you're going to handle your data. Thinking of them as the 3 V's: volume, variety, and velocity can be helpful to be prepared for working with your data.
All right, well, when should you start thinking about data science? I might be biased. I'm going to say, like, it's one of the first things you need to think about. You should always be collecting data about your company, about your users. You'll be really glad that you did when it comes time to actually hire a full-on data science team. So, here are some of the benefits that you'll get. Customer acquisition and retention. You'll be able to model patterns of your consumer behavior. You can learn what makes your users happy. Focused and targeted campaigns. So, to be able to deliver tailored products to whoever your targeted market is. Identification of potential risks. You can create risk management models from data. Innovative products. So this is more on the software engineering development side, but a lot of modern software features use data-driven models. All of the deep learning and machine learning examples that I showed, a lot of those features and the features that we just use today in our phones and in our tech are driven by data science. Complex supplier networks. So this is more about business to business suppliers, but they can use data science to anticipate supply chain issues and be more efficient with serving customers. So how do you build a data science team? You need to think about what your data science team actually works on, what skills are required. You need engineers that know how to manipulate data sets and build models. They need to be able to operationalize those models into software. So there's really 8 technical tasks that every single data science project shares. I'm just going to go through and briefly describe each one. So first, data needs to be ingested from some kind of source. It could be a database, could be crawled from web sources or from your analytics baked into your website or your applications. And usually you might be looking at a large amount of data. So efficiency is really important here. Next, the data needs to be validated and sanitized. So that's the preparation step. This is where errors and outliers are detected. You can remove them from the data set to make your model more conformant. Then you have pre-processing. So pre-processing techniques and then some feature engineering that'll make the data easier to interpret when it's time to digitize the data and run it through a model. So that's where the science happens. Step 4 is discovery. In the discovery phase, this is where the data is analyzed for trends. You're trying to make some kind of meaningful or useful insight out of your data. And then once you understand the data, that's where you're developing the model. So there's a huge amount of AI research around how you develop a model, how you choose a model, what should the size of the model be. It's really just a lot of creative software engineering that goes on here. Training. So every model has to be trained to fit patterns in the data. These data science models are typically self-learning. They're able to extract the patterns themselves. So they're completely automated. They learn from the data sets, and they adapt as they make good and bad predictions. They learn from their own mistakes. Once you have a model trained, you'll probably end up with several different versions and qualities of those models. So they all need to be tested and analyzed and compared to each other. Then finally, once you're settled on a model that you like, this is where you have to operationalize it. You deploy it somewhere as software, produce the reports, the analytics dashboard. Usually we're going to monitor that model, and we'll probably make updates to it as you aggregate more and better data in the future. So most data science teams have 3 different roles that oversee this process. The roles somewhat overlap. You have a data engineer, a data scientist, or a machine learning scientist, and then an ops engineer. Yeah, forgive me for just reading this slide. I think these roles are really important. A lot of companies break down their teams this way, like Google does it, Microsoft does it, a lot of startups do this. You really do want to try to have these roles separate on your team. It's a pretty standard team structure. So the data engineer is responsible for ingesting, preparing, transforming the data, getting it ready to analyze and build a model around it. So they're going to actually curate and acquire the data sets from any number of sources. They're going to figure out how to store and manage your data, control any kind of changes that happen to this data over time. And they're going to develop those efficient pipelines to get the data out of your data lake and into the development environment for the scientists to use. Sometimes they'll even help with pre-processing the data, which is an additional step just to make the data more interpretable. Your data scientist is the one who's actually building the model. They're usually responsible for getting the high accuracy, making sure the model works as well as it possibly can. They develop the model, they train the model. You want them to try to produce some kind of repeatable, portable, reproducible code base. And then, ideally, like all of their experiments are well documented. They can present their findings to management, to the team, because they're really the ones doing all of the statistics work and pointing out all of the trends. The ops engineer, there's a subfield of DevOps that we call ML ops, and it's just completely centered around operationalizing data science models. So, the main goal is designing a scalable, continuous deployment environment. This person is optimizing the model, making sure it runs as quickly and performant as possible. They're going to deploy the model and hopefully automate the deployment and testing. For a lot of models, if you're serving these models to a lot of clients, maybe it's performing a service on your website or in your app, then this person is going to figure out how to auto scale and load balance, how to make sure that there's no downtime and the model can serve as many people or as few as you need it to and run at an efficient cost. They're also going to be running experiments, to A/B test different versions of the models, see if one has a better effect than the other. And usually this person is also, building the whole monitoring system around the model so they can monitor user behavior. How do you interact with the models? How do your customers interact with them? And how can we get that information to be shared in like an edible way for all of management and anyone who really cares at your company who can make decisions from this model. And then finally, there's a particular branch of data science called online learning, where you can continuously update these models automatically as they're in production. There's a way to set these up to improve themselves over time, and usually this falls on the ops engineer. So these are the types of skills and experience to look for when you're hiring a data science team or just trying to get into data science yourself. Over on the left side, some of these are soft skills: problem solving, software engineering, statistics, machine learning, data analytics, visualization, and communication. And usually data scientists have some kind of STEM degree. I myself have a computer science degree. I've worked with data scientists who started out in like mechanical engineering or electrical engineering, and then ended up picking up programming, and then ended up picking up data science. There's a lot of overlap, but it is very much a technical field. On the right side, these are probably the most common types of tools and technology that you'll see at companies that use data science. There's much more than this, but these are the ones that I see most often in job postings. Python and R are usually for scripting or building models and applications. There are a lot of data science libraries that make data science development a lot easier in Python and R especially. SQL is, is the well-known language for, a query language for storing and retrieving and reporting data. Jupyter, Sagemaker, and Google Collab. This is sort of a more recent platform for working in data science, but they're essentially interactive software notebooks, and they allow you to mix code and documentation and reporting and visualization all in one file. So it's great for experimentation. It's really common among like machine learning scientists and data scientists especially. Tableau, Power BI, and Jump. I'd call these no code or low code data analytics solutions. Some of them have machine learning built in, so you can use a wizard or drag and drop to build machine learning models. So you can actually get pretty far with any of these if you have data without really knowing the specifics of, well, what's a neural network. For the programmers, Git, I feel like should be a requirement for all software engineering. It's the most common version control system that's out there. So what that means is developers can collaborate and track changes to their code without overwriting each other, and you can do change control management that way. GitHub, Bitbucket, GitLab, those are the three most popular hosting platforms for code. Then you have Amazon Web Services, Microsoft Azure, Google Cloud Platform. So these are all cloud platforms that can host and serve data science models. You can use them for development. They're a pretty common alternative to like running on your own hardware. And not just startups are doing that. A lot of major companies are now relying on cloud technology. And then lastly, we have Dockering Kubernetes. So these are really convenient for deploying and managing models or software applications in production. This is what handles like setting up a deployment environment for your software and being able to auto scale and load balance your applications. Okay, so data science work is really computationally heavy, especially with larger data sets, with more complex relationships. So if you're thinking about doing this at your startup, you really need to consider the hardware costs or the cloud costs to run these kinds of algorithms and to support your developers. Most deep learning algorithms, they work better on GPUs. GPUs are graphical processing units as opposed to CPUs, which are just, I guess, compute processing units. Sorry if I don't remember the exact acronym, but GPUs are actually designed to display information on your screen. Maybe I'll explain this in depth later if someone cares to ask the question. It would take a while, so don't. But essentially graphics processing units are optimized for matrix math, right? They're projecting information onto a 2D screen, so they're really good at fast parallel matrix multiplications. And it just so happens that deep learning models and deep neural networks, they operate under a lot of the same types of matrix multiplications and the same kind of linear algebra concepts. So GPUs, even though they weren't invented for machine learning, they happen to be very, very effective at machine learning, but they're more expensive than typical processors because they can take advantage of the parallel computing. The box on the left is an NVIDIA DGX. It has 8 GPUs in it, standard. Those can cost a few $100,000 and they use a lot of electricity. I've worked with them. They're super loud too. So it's more of an investment. Like you would need a soundproof case if that's anywhere in your building, definitely. There's nothing wrong with using them. But I've noticed a lot of companies now tend to opt towards cloud infrastructure. So what you see on the right, AWS, GCP, and Azure. That way you can pay as you go. You can scale and rescale more easily. Also, GPUs are available on all the cloud platforms if you need them, when you need them. So you can do development or even actual deployment on cloud platforms. Either way is a good way to go. It's just going to depend on your needs and your budget. And if you have a team to manage one or the other, it requires a different skill set either way. All right, so there's a lot more to talk about. If you want to learn more on your own, especially the technical side of data science, these are some of the resources that we recommend. For me, I was originally a simulation programmer, and I switched into data science maybe after 5 years of programming simulations. And a lot of that was learning on my own. I know a lot of people that have made the same journey. When I was graduating college, there weren't a lot of data science degrees, and I'm seeing a lot more data science and AI focused degrees now, which is fantastic. There are a lot of great resources out there just to get into this and learn more. If you want to be technical or non-technical, either way, I recommend all of these. I'm going to shout out this specific O'Reilly book over here. It's called Hands-on Machine Learning with Scikit, Keras, and Tensorflow. It's pretty technical, but it also covers a lot of the concepts very well. It covers classic data science all the way up through modern deep learning, with GPUs, without GPUs. There are practical examples of code in the book, but you can also just read. I mean, there's tons of just natural language content in there to read through and understand. If you're a founder and you just want to know more about data science, I would even recommend this book just to read through it. You don't have to do any of the examples, but like if you just were to read through this book, you would learn a lot about what data science can do for you, what the different models are, what they can and can't do, what kind of skills are required. So I've recommended this book to all kinds of people, technical and non-technical. I'm also going to shout out Kaggle, kaggle.com on the right side there. So they're a website that hosts data science competitions with cash prizes on behalf of real companies. One example is Zillow.com paid out a $1.2 million bounty for an algorithm that predicts house prices from key features like location, number of bedrooms, and all of that. So there's some really heavy bounties on there. Another fun competition is every year Google hosts a competition to predict the winners of March Madness, the men and women's tournaments. And they release all of the like play-by-play data for every historical game ever. It's an absolutely insane data set. Kaggle is really great. You see a lot of data scientists team up on that website to work on competitions together, share code. Kaggle hosts all of this code. They have a ton of really great tutorials at all different levels for even very specific subfields of data science, even just learning to program or more advanced stuff. And they also host a lot of open data sets as well.
Yeah, you can even take a look at how other people have worked with those data sets when you're trying to get a data set to practice and learn more on. There's definitely beginner to complex problems to solve using those. Another website that's a good resource is DataCamp. DataCamp's one of the websites that has like a way to learn programming languages for data science on the website. So you can do practice problems and be exposed to concepts that build on each other in R or Python, like we mentioned, SQL, tons of other languages, whatever whatever you and your company are using. There's just probably DataCamp or another similar website would have practice problems and the ability to get your toes wet and just try out some modifying data and working with data examples on there to really get the practical building blocks. In addition to learning through those resources, reading up on it and doing practice problems, Greg and I have found that a really valuable way to learn more about data science and feel more confident in being a data scientist and working in data, working tangentially to data even, is networking in analytics and data science. Here we have two examples, one national conference and one local. Nationally, it's great to go to meet lots of other data people, practitioners, data scientists, and analysts, leaders in the field, hear from them. The Data Connect conference is actually held in Columbus, and I've been a couple of times. It's pretty accessible to us. It'll be June 2nd and 3rd this year, and I'll be there again. I would definitely recommend that one. But obviously, there's tons of conferences, especially conferences that have a domain element, right? That maybe if you're in a different field, there's probably a conference related to analytics or data science in that field. All field it touches. So I definitely encourage you to get out there, use the vocabulary that hopefully you've picked up a little bit more today, and ask questions, listen to talks, follow up with speakers, meet other attendees, hear what other people are doing, and be inspired, get excited about data science in person. On the right side, you see there the data science meetup that's going to be coming up in the Meetups at Union Hall series. On the next slide, we have some details. Our first one is next Wednesday, April 20th. Like Brian mentioned, they're the third Wednesday of every month. We have this first talk scheduled to be led by Lauren McDonald, a principal consultant at SEI here in Cincinnati. She'll be talking about event streaming at scale, enterprise methodologies for on-time data. This meetup is designed to be a place for data people broadly to come meet, be together, ask questions, learn from each other, connect, talk about the things that matter to us, things we care about, the problems we're facing, and learn from each other. It's been a while since we've had regular in-person opportunities to meet and connect, and that's a really valuable thing for us as data people, for each other, for the community, and we're really excited to be gathering in person. So we definitely encourage you to come check that out. No matter what your level of experience or connection is, this would be a great opportunity to learn. We have one more slide that just will show our contact information if you want to move to that. We'll take questions now, but we just wanted to give our emails. Feel free to connect on LinkedIn or shoot us an email with questions or ask them here. We'd be happy to chat some more here.
Awesome presentation, guys. And so we're going to jump into QA. There's been a couple questions asked already within the chat, so please keep those coming. Before we do that, I open this by saying that all of this can help a startup win. And it's funny throughout this presentation how much this brought back for me. So my wife and I founded a company called StreamSpot back in 2010 as a live and on-demand live streaming service, basically. And why that's important to data science and how it led to the eventual exit of that company kind of came together in the presentation both Elizabeth and Greg just exemplified. So the biggest problem we had was measuring viewer analytics. So measuring live video viewership is a very complex situation. There's two ways to do it. You can either have a client locally on the video player that is pumping meaningful data out to a data storage device, SQL database, something along those lines, or you can use the consumption logs from your CDN, because both are good, valid data sources. We opted for the latter, which was basically a bunch of fragmented video consumption by IP address. That doesn't tell anybody inherently anything about viewerships, right? So what we did is exactly what Greg showed in that model. We layered ancillary data sources that made that data make sense. It's the preparation that they talked about. So we tied it to geographical locations, and then we tied the user agent to the type of screen that they were using. So now that picture is coming together, but it still doesn't give you the video journey while they were consuming a live video, right? So then we layered the actual video linearly over top of each viewer so that when our customers went to our analytic dashboard, they could see exactly what portions of their content made viewership grow and what made it decrease. And it ultimately became one of the selling points of our company, because there was lots of live and on-demand streaming providers out there, but none of them were showcasing data to their customers the way that we were. And it ultimately made us appealing for purchase. And everything Greg said was extremely important too, because we sold right before COVID, so we saw dramatic use in the platform afterwards when everybody needed live and on-demand streaming. So these concerns about making sure that your infrastructure can scale to meet that demand is extremely important. So any startup on the webinar, everything they said, you're looking at living proof. It is valuable. It can help a startup win, and I just thought it was great. So. With that, there have been a couple questions. So First was from Tyler. He said, is dating mining helpful in marketing? Can it help businesses understand each consumer individually and therefore allow them to customize the type of content they broadcast to them? And I will let you guys jump in. You just tell me, let me go ahead and mute myself.
Yeah,
Speak
I'll
to that.
start.
Oh, go for it. Yeah, you got it, Greg.
I'll just shout out, like, you might want to look at a tool like Mixpanel for something like this. There are a lot of like analytics dashboards out there that are great for aggregating data. And I know Mixpanel is one that's specifically built around the concept of building user profiles, around like your individual consumers and trying to categorize them.
Yeah. Another thing that can be helpful is using a customer segmentation to augment your customer data with some more context about them to know how to target marketing to them. And those segmentations are built off of different data sources. I mentioned census data in one of the examples I gave during the talk. Knowing demographic information, but going way beyond that to other parts of a consumer's life can help to segment and target things. So maybe you're consuming that, maybe you're using that to target, but maybe you have the capacity to be building it yourself. If you have the resources there, or you're just able to connect with other people who have already built segmentation. So that can add a lot of context marketing wise.
Awesome. Before we jump on the next one, so you guys touched on it a little bit about the machine learning side of things and kind of this idea of artificial intelligence. Can you explain for the group and personally for me as well? I think there's a misconception that these computers can just inherently learn on their own. If I understood the presentation correctly, there will always need to be a human to at least help with the training portion of it, right? It's not like you just give a data set to a computer and it all of a sudden just starts giving you valuable information. Can one of you two speak to that a little bit?
Okay, so I hate to put myself out of a job a little bit, but the fact is less and less human intervention is needed to build these things. There are a lot of low code, no code, completely automated data science systems out there. I'll just give an example. If you're on the Google Cloud platform and you're piping user analytics from your website, from your app into something like Google's BigQuery or one of their database data sets, it's almost just a point and click operation to turn that into a machine learning model on the Google Cloud platform. And I'm sure Azure and AWS have something similar. Now, this is going to depend on the complexity of your problem, because AI is a seriously evolving research field right now. There are a lot of really complex problems like computer vision and understanding of language and understanding of code and technical language and technical documents. All of those problems are really difficult and still require a research team. But the fact is, we're trending towards automated machine learning solutions, and data right now, it really is 80% of the work for a data scientist. It's going to be 99% of the work at some point. A lot of the modeling is getting automated, but today, what the role requires is someone who understands how to build these self-learning models. And there are a lot of libraries that help with this. Google has TensorFlow. The Facebook had put out PyTorch a few years ago. They maintain an open source library for building these, and really it's becoming more and more accessible to normal developers. It used to be that really you had to have a PhD level education to build any kind of deep learning neural network algorithm, but today that's not really required. Today, a high school student with programming basics could start learning neural networks. So I almost hate to admit it, but it's just a testament to how great the automation is and how great the tools are. We really are trending towards just a more hands-off approach, but we're not quite there yet.
One of the things that'll be, I think, last to get automated or to happen automatically is finding the right solution for a problem. The human still needs to understand what problem you're really trying to answer and make sure that the solution that you've chosen is addressing that problem in the best way, efficiently, and is giving valuable output, right? The machine will have a hard time having that context to be able to do that, whereas a human has the experience to do that. So it looks like definitely machines are getting more and more intelligent. and able to do more and more and make more decisions autonomously. But you need that human to set it in the right direction and make sure it's still going in that right direction to be producing valuable insights.
Great. So translation for all of you on that are looking to go into the data science field. Humans are still very much required. And I can tell you, as a person that tries to source talent for startups, they're in extremely high demand right now. There are probably 50 jobs to every data scientist that's out there. And lastly, for those who are worried that these computers are just going to take all this data and, cause the apocalypse, somebody can still unplug them. So the humans are still very, very important. Which is a great segue into the next question from Daniel. How did you gain the confidence to feel like a data scientist as you were getting started? And what are your recommendations for newbies?
I'll go real quick. I'll shout out Kaggle.com
yeah.
again. It's a big community of data scientists who help each other out. You can upvote, downvote solutions and collaborate with people. That's probably the best way to get feedback. And especially if you're kind of shy, it can be somewhat anonymous. But really, and I think this is true for learning any kind of software engineering discipline, you really have to practice and build stuff yourself. And ideally, you're open sourcing your code. You're letting other people look at it and criticize it and roast it and help you improve. It's very important that you actually meet with and connect with mentors and people that know what they're doing and can help guide you.
Totally. My experience, I know Greg mentioned people coming from different backgrounds and maybe also having more data science, data analytics programs, majors at universities. I actually came from the data analytics major at Ohio State. And in my undergraduate experience, what Greg mentioned about doing projects, that was a huge part of it, building my confidence. I took every opportunity I could to do hackathons and case competitions and things like that. So outside of a university context, hackathons are still an option. Things like Kaggle make that really accessible to be able to do a project within a certain timeline or on your own time or whenever you want. Sharing that, maybe posting with an open source data set, you can make your own slides, make your own insights, and post them to a website, to Kaggle, to LinkedIn, to send them to people that you think could give you feedback. Ask for that, talk about it, work collaboratively, ask other people to do the project, to work on a project with you. You're never going to be working totally in a silo in data science. It's a really interdisciplinary field. So real projects give you an opportunity to ask questions and to get hands-on experience. But I would say also a big part of learning for me and gaining confidence was knowing how to ask questions and what things to listen for, what things to watch out for that are going to be important to learn about and in analytics for me. So that's where coming to things like this and hearing our perspective on analytics and just hearing all of the terminology we use and how we talk about it and what we highlight, what's important, do more of that. Show up to spaces where people are talking about analytics, using the language, sharing their perspective, talking about what's important to them, how the different things relate. Follow up and ask questions. Use that vocabulary for yourself. Poke at things that don't make sense or you're curious about. There's a lot to being curious as a data scientist, and that starts when you're learning and just diving into things that intrigue you and asking questions. So put yourself in those environments where you get to practice, but also be with people who can share their perspective and be people that can support you and answer your questions and help you grow and learn more as a data scientist. And you got it. There's so much you can do even with a little bit of knowledge. A lot of companies have data that needs to be analyzed and problems that need to be solved. So as a data scientist who's learning and growing, don't undervalue, don't undercut your skills. They're even being able to do basic things with data is powerful and is something that's definitely adds a lot of value and is worthy of being used and shared and applied. So I definitely encourage you and keep going. You got it.
That's great advice. So we're going to do one more question here, and it's a great one. Another thing we started with, it does not matter the type of business that you do or what your tangible output is, data science can help. The question is, how can AI data help a consumer goods company that has physical products? And before we answer that, It's a good segue into our next upcoming event, which is on May 26th with Kinetic Ventures. And why it's a good segue is Kinetic Ventures does their intake. So the ingest that Greg talked about, different than other venture capital firms. They are basically taking attributes of the founder. So think of like Myers-Briggs, Strength Finders, those types of things. And they have crafted an AI/ML model that determines what makes a great founder. And I'm not saying it's right, wrong, or indifferent, but there is some science to it, and they are seeing some success as far as the exit percentage, the ones that go on to raise more money. That is an example of a human element to all of this. I gave an example of a very technical one. But the question is, how can we do this with physical goods? Very interested to see what the answer is. But my question or my suspicion is it probably can help a little bit. So,
yeah, I'd say a little bit. There's a ton of examples that come to mind, and a lot that I've worked on personally. Though I can't go into specifics there. One thing you can track is just who's buying your products, right? And like not just who, but who, like what about these people is making them buy these products? What do they like about the products? But a more interesting software like application of AI and data science to this, would be optimizing the products, and defect recognition is another one that a lot of companies are interested in today. You're producing these physical products, and when you're producing stuff at scale, it's hard to do quality control for these. A lot of companies right now are still doing manual quality control, or they have some kind of, system that might quickly take a picture of your physical product. And that kind of machine perception of images or scans is one of probably the most mature applications of AI and machine learning right now. Being able to automatically detect defects from a picture or from some kind of sensor readout, it completely automates away a lot of tedious manual, work for someone who's just going and repetitively checking products for quality control. So that's one area that I've noticed a lot of companies with physical products are starting to use machine learning for.
Totally. Having not worked in CPG before as a data scientist myself, I don't have all the examples that CPG data scientists would, but I think it'd be super, super cool for you to connect with someone that works at a company that, here in Cincinnati, P&G. The Smuckers was a sponsor of the analytics org that I was involved with at Ohio State. They had some really interesting use cases that they talked about. I know one of the most basic things when you think about big data, or one of the most earliest, maybe not most basic, is that when you have a loyalty card for any store, that's the way that you tie a consumer's purchasing on the first level together across time, across locations. So it might seem like you're just getting discounts, but that's a company collecting big data, because across tons and tons of people and tons of time, that makes a huge data set, and that's super valuable. Like I talked about augmenting data with more context about a customer, from a marketing perspective, you can do the same thing, adding demographic and other information to customers to understand the purchasing habits. You've heard of maybe the classic or the anecdote of Target predicting when someone is pregnant before they knew, sending them marketing. So CPG companies have tons of data and can use it in really cool ways. So really powerful ways also. There's obviously a lot you can grow, do more, be curious. But I think a CPG data scientist would have a lot more of future traction there too.
Awesome. Well, first and foremost, I want to thank our subject matter experts, Elizabeth and Greg. Thank you for giving up your time today to share your big, beautiful brains with not only me, but our entire audience. We sincerely appreciate you helping our startups win. I hope everybody that tuned in today learned a lot about data science, but the good news is it does not stop here. Next Wednesday here at Union Hall, go to Eventbrite, search for Centrifuge. It's the next event in our series. Come meet a bunch of us, see Union Hall, talk to Elizabeth, talk to Greg, and then let's keep this going. This is the spearhead of what's going to get meetups back at Union Hall. So we're super excited about it. Thanks again, everybody, for joining us today. There will be a recording of this, so we will post that on our website, centrifuge.com. And we look forward to seeing you at the next one on May 26th. Have a good rest of your day.